Hey, welcome to Swell Academy today. Mr. Math here, working on some one-step equations, some average, some percentages, some prices. We're back to using some white paper, so I'm gonna take the opportunity to use some light colors today. First, I want to introduce you to a question. And keep in mind, when you're going through this, underline some key points. Some of this could be, the average of 30, could be, not necessary to answer the question. Talks about a seventh game. And what they want you to do is come up with an equation that could be used to find P. P will say we're using for points. Always like to introduce, a little warm up or review where they're talking about averages and what is that. So an average is basically a sum of all your data. It's everything added up. So in this case, points. And then that sum is divided by a number or count. In this case, games. And what that does is gives you a number in which if you were to play an additional game, that's most likely the number you would get. So in this case, he has an average of 27 points over 6 games. So that seventh game, odds are he's going to score somewhere around 27 points. Now, that doesn't always need to be the case. And just a quick example of how to find an average. Here you have 3 data points, 2, 4, and 6. And because you have 3 data points, you divide by 3. You take that sum, divide by 3, and that'll give you your average. And you see both of these are basically off by 2, so that's why 4 kind of ends up being your average there. So we're going to look at this question here, and it talks about, okay, so he had 6 basketball games. That means that I'm basically dividing by 6. A certain amount of points that was going to give me an average of 27. So let me set that up there. Now, do I need to know how many points he scored each of these games? No, but I need to know the total of which he had over those 6 games. So let's solve for T, or total points here. And in order to do that, I'll multiply both sides by 6. And I get T is equal to 162. So basically over 6 games, he's scored 162 points. Because if you take that total amount of points and divide by 6, you would get an average of 27. Now, when they're asking about, okay, how many points does he need to score in the 7th game to raise his average to 30? So set that up again. Okay, this time we're talking about 7 games. We want an average of 30. We know over the course of the 6 games, he had 162 points. This represents the 6 games here. And then this X is going to represent, or we wanted to say P in this case, this P is going to represent the 7th game. Now, same thing I did in the other question is basically multiply both sides by 7. Get 162 plus the points for the 7th game equal to 210 minus the 162. Simple one-step algebra problem here. And Mike would have needed to score 48 points in order to get his average up to 30. And I think this is pretty cool because since he's had quite a few games and he's kind of set on an average of 27, look how many points he needs to score just to move his average up by 3. He needs to basically score an additional 3, 10, 13, 21 points, right? He needs to score another 21 points on top of his average. On top of his average of 27, get 48 to get his average up by 3. Something very cool to look at there. Next question I want to bring up is, you're kind of simple. Someone has a company and they're selling a case. Now, again, it helps to make a list there. So I'll say RC, rechargeable case, costs 15. and this is how much we sell them for. And then company costs $5 to produce, so this is the cost. That's a big number. So we'll say cost produce is $5. So basically for each case, they're making a profit of $10. And if you want to say, well, how many cases you need to sell in order to get 1,000 cases, well, you could sell, well, if each case gets me $10, then I need to sell about 100. Now, it's not always easy with the 15, the 5, and the 1,000 with easy numbers. So you do want to set up an equation. And then you also at times want to look through certain questions, because it asks you to create an equation. That's important. That's what they want. And then determine the amount of cases that would need to be sold. And then they want you to solve, meaning like how many cases is that? And you have some sentences where this includes labor, materials, etc. That's not really important part there. Could confuse some students. But basically, what are we doing here? You're selling a certain amount of cases. You don't know how many, so we call it X. And each of these cases is gonna make you $15, or with before cost, minus the $5 per case. So if you sell a case, again, you make 15, but you also lose 5, and you want that to equal 1,000. And that's how you could solve for this. Like terms, right? CLT, like terms, 10x is equal to 1,000 divided by 10. X is equal to 100. And here you have, a way where you're making a list and then you're moving it to an equation, which is important. Sometimes standardized tests like the SAT is going to ask for this equation rather than the answer. So it's important to work with. Another thing you might want to consider is if they ever add this startup cost, they'll call it. So keep an eye on this. It's not in this question, but I am bringing it up. And basically what that's saying, you're selling cases for $15. Each one costs $5. But let's say to build your building, to make these cell phones and sell them, costs you $200. This is a one-time, what we call a fixed cost. You'll learn this in finance and whatnot. And that costs 1,000. So you have something added here, and basically do not make this a like term. And then actually, I'm sorry, the startup cost, if it's something you're built, is going to be a negative. It's something that's gonna cost you money there. I think my red marker has gone on me. So this would actually be a negative here. So you're actually gonna add the 200 to both sides. 10x equal 1,200, divide both sides by 10, and you can recognize. Now, a good way to divide with zeros is just you cancel out the zeros. 120 divided by 1 is 120, and if you notice, we need to sell an additional 20 cases to make up for that $200 cost. So keep an eye on that startup cost. It's just like a one-time thing you're adding to your equation. And then another good question that you'll see, SAT, a lot of algebra books like to use this type of question, is the discount question. Now, what I like to bring up is just kind of explain to you a little bit about discount, increase and decrease. So you look at a discount, basically it's taking a certain price. Let's use $100. Best number to use when dealing with percentages, okay? Because any percentage of 100 is that number. So basically 35% of 100, moving 2 decimal places to the left, is that number. So if something was selling for $100 and there was a 35% discount, I would take off that 35% discount and get 65. Now this is a two-step way of dealing with this. There is a way in which you can take your discount, subtract it from 1, like if you want to put it in a calculator, and then what you end up with is, and if you look here, a 35% discount is basically selling the product for 65% of its whole. because we took the whole piece, took the 1.00, basically 100%, and we took away the 35%, 100% minus the 35%. I think it's good to look at that too, and got 65%. That's how much it's going to sell for, and we got $65, which is what we did in one step, where here it took 2 steps. So in this question, let's take out and list some of the information. Okay, the discount is 35%. Final cost, FC, that's a good acronym to use for final cost, is $58.50. So meaning after I sold these pair of vans at a 35% discount, they cost $58.50. So this is a great question I like to bring up, because it's very easy just to give you the price and tell you to multiply by its discount and then come up with the answer. Here they're giving you an answer and they want you to come up with the original price. That's a big question I like to ask. So what I'm going to do here is say, okay, we don't know the original price, but we know that it was discounted by 35%. Okay, now if it's discounted, you subtract it. If it's a price increase, let's say the price went up 35%, it's just simply X plus. Let's say it went up 20%. You would just add. An increase, you would add to the 100%. Decrease, you're going to subtract from it. And we know that this equals $58.50. So let's do our parentheses. Let's recognize that a variable next to a parentheses is in fact multiplication. So we're going to use division, get x by itself, dividing both sides by 0.65. And then if you take a number and divide it by a number less than 1, it's actually going to give you a result that's a bigger number. So it's going to give us 90. And we know that our vans were $90. And if you took those vans and multiply it by 0.65, you would get this number here. And that's basically how you solve for an original price given a discount and a final cost. So we looked at average, kind of that profit question, and we've looked at here a percentage or discount subtraction, and if it's an increase or a tax, then you'll just add. Remember, just practice these questions, add the failure, and then you'll get the success. Hope this helps. There'll be another video kind of with 2-step questions coming up. Thanks for stopping by.